Welcome to section 5. For section 5, we are going to be looking at unsupervised learning algorithms, going the NoCode route. So this course delves into the world of unsupervised learning, emphasizing the understanding and application of key algorithms in this field. It is suitable for individuals with basic machine learning knowledge, which you already have from the section 1, who wish to deepen their understanding of unsupervised learning techniques. Beautiful. So, table of contents, we'll be looking at unsupervised learning, introduction, anomaly detection, clustering. Then we'll go through the studio wizard route for anomaly detection, the studio wizard route for clustering, and we'll look at the studio route for both anomaly detection and clustering. Okay, unsupervised learning. This is a branch of machine learning, and it's actually a very interesting branch of machine learning. Unsupervised learning is a type of machine learning where the algorithm learns patterns and structures in data without explicit supervision or labeled training data. The machine learning learns from the data without you saying this is a target variable. So it just looks at the data and comes up with an understanding. Looking at every single row, comes up with an understanding, and it's able to come up with brilliant understanding from the data that it has looked at. And in other words, it involves finding hidden patterns or relationships within the data set without the algorithm being told what to look for. And yes, unsupervised learning is actually a beautiful part of machine learning. Yes, here are some key characteristics and technique associated with unsupervised learning. No labels, yes. Clustering, yes. So clustering is a common task in supervised learning. It involves grouping data points into clusters or categories based on similarities or other criteria. I'm going to explain every single thing. The anomaly detection, yes. Unsupervised learning can also be used for anomaly detection, where the goal is to identify data points that deviate significantly from the normal or expected behavior. Yes, and density estimation. So these are some key characteristics and techniques associated with unsupervised learning. We're going to go deeper into some of these components that we just called, especially the area of clustering, anomaly detection, even density estimation later on in the course. So look at the image to the right. We have the onion, bell pepper. Is this a pear? I don't know. Yeah, good. So all of this unlabeled data, and the machine looks at this and says, oh, I can see items of similar color and similar shape. And what it does, it groups those attributes, those items with similar attributes, and take them in clusters. So this is where clustering comes in. It just clusters them. So you can see it brought out all of the pepper. It brought out all of this item here. I don't know if it's a pear. And it brought out all of the onion. And yes, this is a beautiful part of unsupervised learning. And this is where clustering comes in. So unsupervised learning is a type of machine learning where algorithm learns from unlabeled data without any predefined target variable. Okay, and yes, it's actually a very powerful tool for discovering hidden patterns and insight in data. And it is widely used in data analysis, machine learning for a variety of tasks where labeled data is scarce or unavailable. So there are so many applications, either in the finance space or in the insurance space, like for transaction monitoring. So the bank might not have started doing anything related to transaction monitoring, labeled as in labeling of the fraudulent transactions in time past. So by the time you bring in unsupervised learning like clustering or anomaly detection then looks at those particular transactions and begin to classify which transaction looks like a normal transaction, which transaction looks like an abnormal transaction. And that is actually a good place to start for a fraud activity, because each of the bank customer have a particular behavioral pattern, and when there's a drift from their behavior, that's a flag, and the machine is smart enough to detect those drifts. Okay, so anomaly detection, yes, just like I've said some seconds ago. So if you look at all of these fishes are moving to the left. So let's say all of these fishes are single transaction for one person called Mr. John Doe, and all of his transaction is following a particular trend, yes, and it's always moving towards the left, and sometimes it does a bigger one, sometimes it does a smaller one, but one of his transaction is going off. Either he logs onto the bank at odd hour, he is trying to initiate an amount that is higher than the normal amount. Those are off transactions. He's trying to send money to a destination which is outside his country or jurisdiction. Off. He sends in a week, he does 5 to 6 transfers, banking transfer, and all of a sudden you're seeing that he's doing 50 something transfers, and he's doing transfer of a higher frequency, like he's sending 1,000 naira 100 times in 1 minute. Off. So yes, so the machine is smart enough to flag several, and it's not just in the financial space, in the insurance space, in the health sector, and several other sectors. So the machine is smart enough to look at transaction that looks abnormal. Even when you are training some deep learning model, especially in the area of NLP, and you don't have labeled set of data to actually vet the model you've built, the NLP model you've built, if it's accurate or not, you can then take out some approach in the area of unsupervised learning to begin to track some interesting insights that the machines are actually pushing out. Okay, so we can see this other chart here, value to time. And value to time, we can see the transactions have like a definite path until there was a spike. That's an abnormality. So imagine this happens to be a banking transaction. What the bank is going to do here, when there's that spike and the machine has said, oh, this transaction is an abnormal one, not necessarily a spike, it can be even a lower one. This transaction is actually an abnormal transaction. It's different from the behavioral pattern of Mr. John Doe. So what the bank is going to do, the bank is going to send an extra form of verification or authorization to Mr. John Doe. Hey, an activity is trying to happen on your account, and this is just for you to vet if you're the one initiating this transaction or not. And Mr. John Doe says, oh yes, I'm the one, and the bank can then honor that particular transaction. But the bank has to send in the authorization in a channel that Mr. John Doe is like an SMS format or an email, ensuring that the hacker does not have access to those other channels. As simple as that. So several business logic can come as to treating an abnormal transaction. So that particular scenario is for the finance space. Okay, so fraud detection. Like I was speaking on fraud detection, transaction monitoring, spotting irregular transactions that may signal fraudulent activities. Risk management, identifying market anomalies to manage investment risk, very important. Anti-money laundering, yes, monitoring transactions, detect pattern indicative of money laundering, very important. Credit scoring, using anomalies in credit scoring to assess credit risk. Yes, sometimes you might not have the full information to really vet credit risk, but when anomaly detection comes in, it gives you a more advantage. So by the time you're calling two AI models, so an AI model that is trained on labeled data for a particular finance on credit scoring, and there's another AI model that is trained again on anomaly detection to evaluate risk of each of those individuals that you're trying to score. So the both of them working together gives you an extra security guarantee. Yes, so cybersecurity, detecting cybersecurity threats through unusual network or user activities, very important. You see, Mr. A has this pattern across this network, and all of a sudden, Mr. A is logging into the network with a different IP. Aside a different IP, Mr. A is trying to move a data size that he has not moved before. There are just multiple ways, and the machines are fast enough to track these things and block these transactions. Yes, operational anomalies. Good. So clustering, which is another aspect of unsupervised learning. Now, clustering is a machine learning technique used for grouping similar data points into clusters or clusters of data points that are similar to each other based on certain features or characteristics. Yes, like we saw for the fish, no, like we saw this particular data set, the cluster algorithm was able to cluster all the peppers and cluster all of the yam and cluster all of the onion. Yes, so similarly, you can see this particular graph that took out items of similar colors, cluster them, yes, based on color property. And there are so many properties beyond your eyes, beyond the column names that you have on your database table that the machines can see. It can analyze both spending patterns. It can analyze several behavioral properties of each of your customers and come up with an interesting subgroup. Yes, so and this has a whole lot of benefits for businesses. Like example, like in the marketing space, you want to engage people of this particular subgroup, so you can then engage those subgroup based on what they are properly classified for, and you can be sure that if you are giving them that content based on their classification, you are sure to get better conversion. So image segmentation in computer vision, another one, document categorization in natural language processing, anomaly detection in cybersecurity, genetics for grouping similar genes or protein, recommender system for identifying user preference. Yes. So if you look to the right, you will see this small tabular data set, customer ID, general, age, annual income, and spending score. And yes, we are going to play with this kind of data set later on, and we're going to cluster each of these users and make it very easy for us to send targeted ads or targeted email blast or engagement for each of these users. Okay, so going the Studio Wizard route with anomaly detection. Are you guys ready? Yeah. Okay, so so there's this scenario one, yes, which I provided a data set, and there's this scenario two here, which I provided two different data sets. Yes, so I'll quickly hop on to studio environments. I will copy this particular data set and open the data set on our browser. Beautiful. Let's bring in this data set to our studio environment, and I'll call this cluster, create data set, and we'll call this section 5 clustering dataset 1. I'll paste the URL, section 5 clustering dataset 1. I'll create the dataset. Great. So if we visualize this dataset, we can see, oh, it has 2,339 rows and 6 columns. Okay, so type of action, cash in, this is a banking transaction, source ID, destination ID, amount of money that is being moved, and the date it was moved, and the category, type 1 or whatever type. Yes, so you can bring in whatever business table transactions you have. You can apply anomaly detection in different types of database tables, yes, to spot out anomalies. Okay, so yes, we will create a project using similar name. Let's quickly create the project. Create the project S5 clustering dataset 1. Okay, and we'll launch Studio Wizard. Yes, so we'll launch Studio Wizard for anomaly detection. We're going to be keen, and clustering, we're going to be very keen on Studio Wizard. And we'll select the dataset S5 clustering D1. Let's give this some seconds to load up. Okay, we can see this is a categorical variable, categorical numeric date time, no missing value. Cool. Okay, so we'll click on next, and next thing we're going to do, we're going to select anomaly detection. Are you guys ready for something new? Okay, so we type P anomaly, name of the model, prediction of anomaly. Okay, I like to just put underscore model just in case. Not necessary. I'll click on train. So let's give this some seconds to run. Okay, so our model is done running, and it gave us a chart, a plot here. So we can see the 3D design plots identifying all outliers. So we can see all of these transactions, you can see based on normal to abnormal. So the 0 regions, these bluish regions are the normal transaction, and the abnormal ones are the ones with this orange, and deeper with the ones with the orange. So we can always move these 3D design plots. Yes, we can see this data set has a couple of abnormal transactions. So what we're going to do, you can always download this. Yes, this is beautiful. So what we're going to do is we're going to take the data set. We're going to take the entire data set, and we want to see the abnormal transactions. So we take the entire data set, and we pass it as the test data. So I want it to properly classify. So now we're inferencing the model with the entire data set. Give me all the abnormal transactions, and just so we can see them. Good. So we can see abnormal transaction. This is 0. These transactions are fine. This is an abnormal transaction, and can see the abnormal transaction score, anomaly score. You can see this is 1, an abnormal transaction. I don't know why, but the model is flagging this as an abnormal transaction, and we can keep checking to see all other abnormal transactions. And yes, you can download this. Very important. And yes, so now we've been able to see all the abnormal transactions for this particular data set. We can see also this is an abnormal transaction. Yes, that happened 2019 March 09 at so time. This is an abnormal transaction. Yes, so there's a deviation from the norm. This is also an abnormal transaction. Yes, that happened May 30th at so time. It's an abnormal transaction. So yes, this is beautiful. Now so we wanted to see each of the existing data sets from this particular table that we sent is normal and an abnormal transaction. So we're going to go ahead to create a pipeline, and creating a pipeline so that a new transaction that's coming into the banking network for transaction monitoring, the bank can use that new transaction to inference their model. So if the bank inferences their model with that new transaction, the bank can get that prediction. Oh, this is a normal transaction, honor it. Oh, this is an abnormal transaction. So the bank cannot proceed whatever business logic or business behind the scene process in line with their business decisions can process. Either they should demand for extra means of authorization or whatever. Okay, so we'll just enter a pipeline name here. I will call this pipeline wizard pipeline. I'm very poor with naming. Okay, so now we have a pipeline. So what we're going to do now is we're going to inference our model. So I'll open the console environment again, and I'll open quick predict, and I'll select the clustering, and I'll select the wizard pipeline, and yes, we're going to take. So now when you want to push in an inference for this particular data set, now mind you, for supervised learning, we were working with the independent variable, targeting the dependent variable, which was the last item. But for this, there is no target variable, so we are copying the entire thing. So yes, we'll copy the entire thing. For those of you who guessed it right, and then we'll create data sets. We'll paste the scalar, one dimension, and we generate. We have our data set. Beautiful. So we can then pass this data set and use it to inference our model. We give this some seconds to run, and the model predicted this is a normal transaction. So yes, we can predict one more other transaction, create a data set, and this is beautiful. This is more enhanced security for your business. This is more enhanced security for your business. You can identify abnormal transactions, and yes, this is a normal transaction. Honor it. Yes. So because we've been able to create this pipeline, we can copy our data sets. We can try the same thing using Postman environment. Good thing, I already have a Postman payload open here. We update our data sets. We change the one here as 1. Then we copy our project pipeline ID. So we'll click on clustering and we'll copy the pipeline ID of our project, and we'll update the one here. Update the one here. And we'll click on run. And yes, we get a prediction, and beautiful. This transaction is a normal transaction. Go ahead. So this is how super simple and easy it is for you to build a clustering model and inference this clustering model via an API. But the beautiful thing about clustering, anomaly detection, and the beautiful thing about anomaly detection is that it has a very deep importance that is going to save several businesses millions and billions of dollars, especially to cybercrime. Okay, noted. So the next thing we're going to look at is we're going to look at scenario 2. So scenario 2 is actually more interesting. So I took a label data. Let me open it. Label data, supervised learning. Oh, it's messed up. We're going to import it to studio environment now. So I took a label data that had fraud as a target variable, and I stripped off the fraud as a target variable. So I took it was labeled by an institution, and with the fraud, no fraud target variable. We're going to look at it shortly. And I stripped it off the fraud target variable, and I built an anomaly detection, and we're going to see what had happened. Yes, so let me bring in this into studio. Okay, data set. We'll paste it here and compare. So compare one. Okay, and so we have compare 1. Let's bring in compare 2. Then we begin to do our analysis, and this shows you how very important anomaly detection is for your business. And we'll call this compare 2. Okay, so let's visualize this data set. So this is compare 1, which is actually the real data set. Month, week of month, day of week, make of the car, is an insurance company, accidented area, day of week claim, month claim, sex, blah blah blah, up until fraud. So this is a labeled data, and you can see the number of rows, 15,419. And yes, this was labeled by the institution. Oh, this was a fraudulent transaction. This was not a fraudulent transaction. This was a fraudulent transaction. You can see this is a fraudulent transaction. This is not a fraudulent transaction. So they labeled it. Beautiful. And yes, with this you can build, because it is labeled, you can build a classification model out of this. Yes, I'll tell you how to do something very super interesting here. So what Hannah did was I took same data sets and I stripped off the fraud. So you can see it stopped as base policy. So I stripped off the fraud, which is the target variable, and it stopped at base policy. Then I built out of dataset 2 and anomaly detection, and I want to show us the accuracy. You can do this comparison yourself, and yes, you can see this is dataset 1 with a fraud on this Excel sheet. This is dataset 2, and this was the anomaly detection prediction here. So I now extracted the fraud and the anomaly prediction, and you can see the machine said this is an abnormal transaction, this is an abnormal transaction, this, according to data set, this was a fraudulent transaction. The machine did not flag it. The machine flagged that this is an abnormal transaction. So I just hope the business was very clear that why this was supposed to be passed, and beautiful. Here you can see there was a tie here, so there was no tie here. Machine did not detect this, and the machine flagged that this is an abnormal transaction, this also, and there was no tie here, there was no tie here. And if you go through this particular data set, you see a couple of ties, and yes, you see a couple of ties, and you can see there's a tie here, there's a tie here, and to tell you how very beautiful anomaly detection is, and there's another tie here. There are a couple of ties between where the business said that was a fraudulent transaction and where the machine flagged that particular transaction as an anomaly, and the business needs to sit up there. And there are so many ties, and there are many more regions where the machines detected it as fraudulent, and the internal man in the business did not detect it as fraudulent. So now this is now where building a combined fraud detection system comes in, using AI, using AI as an advantage. And how you can do that is simple. So from this label data that the institution has built, so they've been able to label it, you will build a classification model on Autogon AI, and so for a new, and also build from the unlabeled data, build an anomaly detection. So now, then you would make an API request to the two model for every new transaction. So, and they both have to be on no fraud. So you pass in a new transaction that comes into the business. Oh, from your history of fraud, from your knowledge of fraud, is this fraudulent? If this guy says no, and this guy says no, then that transaction should be honored. If this guy says yes and this guy says no, don't honor it. If this guy says no and this guy says yes, don't honor it. Demand for other form of authentication. So this is how to build a robust fraud detection leveraging artificial intelligence. So from known history and from transaction behavior, this is how to build something super robust. Okay, so now we are done with anomaly detection. We're going to look at clustering. Yes, clustering. Again, clustering is another very beautiful part of machine learning models. Okay, so looking at clustering, we are going to open this data set for clustering. Let's close whatever other data set we have here opened here, and close this, and we'll bring this to the dataset environment. We'll paste this, and this is clustering dataset. Okay. Okay, beautiful. So we can visualize this clustering dataset, and you can see it has 5 columns and it has 199 rows, different customers. And like we've seen in clustering, the application is actually vast, from marketing, target marketing, to understanding the groups and relationship between each of your customers and knowing how to engage with them based on restructuring the UI of your web app or your mobile app to target subgroups, down to advertisement, the way it is being pushed, down to newsletters and email marketing, and how you do your weekly engagement. So if you are engaging based on the cluster, yes, this particular cluster, this is their behavior. This particular cluster, this is their behavior. If you're engaging on a cluster base, you will get much more conversion and better traction. Okay, so we are going to create a clustering project, and we'll create a clustering project. We're done. We would launch our Studio Wizard environment. So we'll launch in Studio Wizard environment, and we select the datasets, clustering datasets. Okay. And let's give this some seconds to run. No missing values. This is fine. And so we select clustering. We'll call this P cluster. Good. P cluster. Okay. Beautiful. And this chart has been generated for us. And what has happened here is all of the users were clustered in 4 groups. This group, you can see cluster 1, cluster 0, cluster 3, and cluster 2. Yes, so they were clustered in these groups. And yes, so the machine has spotted that these guys have a behavior that is similar. They have a similar pattern behavior, same as these guys, and same as these guys. And these are stuff that your eyes default would not be able to fetch them out. So now let's hop onto this environment and let's understand what the whole PCA axis means. So the horizontal axis PCA1 and vertical axis PCA2 represent the first and second principal component derived from your dataset, which likely includes multidimensional data on customer demographics and behavior. PCA1 and PCA2 are transformed coordinates for each data point after PCA has been applied, capturing the most significant variance in the data. So now, business implication. So depending on what PCA1 and PCA2 represent, the business can tailor strategies for each cluster. For example, if PCA1 correlates with annual income and PCA2 with spending score, cluster 2 might represent high income, high spending customers, and a prime target for luxury goods. Does that make sense? Yes, makes perfect sense. So cluster 2 might represent high income, high spending customers, and a prime target for luxury goods. So this is how you really engage. So you look at the clusters, understand your business data in line with the clusters, and you can then begin to engage these end customers. Okay, so let's launch. Okay, before we open the second data set, one more thing we're going to do. Now, you can cluster these guys not just by uploading the entire data set on Autogon environment and clustering every single thing once. You can copy the data sets. Let's copy the data sets. You can copy the data sets, and you can then fetch each of those clusters. So we'll predict the entire data set. So we can download it so you can see this guy belongs to cluster 3, this guy belongs to cluster 3, and all of that. And you can download this. Now, let me tell you why this is actually very important. This is actually very important because, so peradventure, your way of using clustering is not just for sending emails. You can also use clustering for customers who are coming on board. Oh, this customer who is coming on board, I clustered him and I have tailored his experience of our app to this particular design. This is brilliant user experience. So yes, you can come up with different clusters, and for this particular cluster, this should be the section of our app that they should visualize upon the landing page. So we'll have different landing page for different clusters. So as soon as the guy has giving us his credentials, general, the age, the annual income, spending score. If we've tracked all of this, so depending on your own business data set, we cluster the particular guy. We see that is supposed to be of a cluster 1. Then we give him an experience tailored to the cluster where our AI model has classified him to be. And this is brilliant. This is very brilliant user experience for your next app or for your existing app. So we've downloaded this. We can create a pipeline. Let's quickly create a pipeline. So cluster underscore model. Quickly create a pipeline. Okay. So now we have a pipeline. What we can now do is, let's open this data set, and then we'll pass in a fresh transaction. So we'll go to quick predict and we select cluster, p cluster model. Okay, p cluster model, and we will copy this entire transaction of the new customer who is coming on board. I want to cluster him and assign him to a particular user experience on our system. And beautiful, this guy is a cluster 3 guy. We route him to where he's supposed to be routed. And yes, we can do this equally using the Postman environment. We'll pass the data set here, pass the data set, and we select the project. Select the project cluster, and we pass the flow ID of the project and hit send, and you can see we've been able to cluster this guy, and voila, we've assigned him to cluster 3. As simple as that. Okay, so let's look at the next data set. So we bring in these data sets to Autogon environment. Okay, we can use this same project. Yes, so let's launch Today Wizard again for this project, and this time around we can even enter the URL of the data set and we load it. So let's give this some seconds to load. Beautiful. So if we click on next and we select cluster, we can call this p cluster 2, just so the name is going to be different because we're using the same project for the both clustering, and we click on train. So yes, we give this some seconds to launch. So just good, beautiful. So yes, so the customers in this data set were clustered again into 4, and let's now look at their exact behavior. So you can see PCA1, PCA2. Let's now look at the exact behaviors. Don't forget, you can always look at the data set and yes, relate it to whatever you need to relate according to your business knowledge. So let's now look at this. So you can see PCA1. This represents the direction along which the area varies the most. So the horizontal axis shows PCA1, which would, as this horizontal axis, which would be the weighted combination of all the original features like age, balance, duration, etc. Given the context of PCA1 could represent underlying factors like overall engagement or financial stability of the customer. PCA2, the vertical axis shows which captures the maximum amount of variance in the data that is not already accounted by PCA1. So it is the orthogonal to PCA1 in the context of the data set. So PCA2 might represent another set of factors, perhaps the customer's responsiveness to previous marketing efforts or their risk profile. So you get to deduce business information based on your understanding of the data set, because the whole PCA thing, dimensionality reduction has happened, and has clustered those guys efficiently. Then you can deduce your business knowledge based on your understanding of your data set. So good. Target marketing. By understanding the clusters, a business can create a tailored marketing strategy. For instance, cluster 0 might receive general offers, while cluster 3 might be targeted with premium services or others that require a strong financial background. See how beautiful this is, giving vodka to who can pay for vodka, and giving a smaller alternatives for who can afford that. So customer insight. These clusters help in understanding customer behavior. For example, customers in a cluster with high PCA1 but low PCA2 might be very responsive to campaigns but have a lower balance, indicating that they could be younger or less affluent customers. Okay, so yes, so we have checked out clustering and anomaly detection using the Studio Wizard environment, that's the AutoML environment. We can also go play with with clustering on the Studio environment. So I've detailed on this material how I played with clustering using the k-means clustering on the Studio environment and came up with a very good accuracy. You can go play with it, and this is data set. And yes, so play with it and let me know via the comment how it went down for you. Beautiful. Okay, and thank you for your time. I'll see you in the next course.